It's called a survey of MySQL index types. My name is Dave Stokes. I'm a technology evangelist in Percona. Been there since February. For those of you who are you, that's a slash model Gibson Les Paul at the Gibson shop in downtown Nashville. Well, it's very rarely I get to touch an $8,000 guitar, but I can tell you more about that later. Anyway, before this gig, I was working for MySQL on the community team for almost a dozen years. So today we're talking about indexes, and without an index, the entire table or file has to be read. Data may not be ordered, it's time consuming, and you can tell by this gentleman here looking through this tome that if he's looking for one thing, it's going to take him a while to get to it. So I'm talking today about NODB indexes. MySQL has other storage engines that I'll be nice to say they're forsaken by Oracle, but NODB is a superior storage engine. So with an index, you gain the ability to go to a specific location that has the information you want. And that way it's faster. You don't have to read all the previous stuff. You go right to the entry you want. So if you want to know something about Cardinal Adrian, you just go to page 63 in this book. So I have to know absolutely nothing about Cardinal Adrian, and I like it that way. So MySQL uses something called a clustered index, and that is built on top of a B tree. Now, for those of you who've been playing around with MySQL for a while, you're going to have to forgive me. I like to give simple illustrations because I get a lot of novices in my talks. And this is one of the talks I've been giving lately. So, as you can see, it's kind of a tree with the trunk at the top and the branches and the leaves at the bottom. And it's very nice that everything's kind of split up. As you can see, the second level, we have 1 to 47, 48 to 1001. On the intermediate nodes, the root node is everything. Intermediate nodes, everything's been split in two. And below that, things have been divvied up again. So this is called a B plus tree. And it's very easy to search for one record or a range. So if you want to find record 22, you have that nice little red path there. If you're looking for a range, you're looking for records between number 17 and 42, it can very easily go out and grab those. It doesn't have to read the stuff in the 1 to 15 or the 48 to 1000. And with MySQL, the records are stored by primary key. And if you do not pick a primary key for your data, MySQL will pick one for you. And like everything else in life, if it's picked for you by something else, it's not going to make you happy. So this is some dummy data. Where on the left we have the primary keys. So the top record, we have the primary key for record 001 and the data for 001. Now, people come back to me and say, well, I don't want to index by a primary key. I have these other things that I want to group together. Well, that's a consideration for something called a secondary index. And the idea is that you want to have a unique primary key that's not nullable for each row. Secondary keys are non-primary keys, and they are used to access records in other tables. Best type is not nullable. By the way, if you saw Bruce Momgen's talk yesterday on nulls, and you can explain it to anyone else, including Bruce Momgen, what exactly a null is, you are ahead of the rest of us. Keys are what make up an index. And big hint is avoid nulls in indexes. And please do not use GUIDs as primary keys. We'll talk about why later. They might make an okay secondary index. So creating indexes are very easy. Now, whenever you create an index, remember they take up space in memory and on disk, and they add overhead. So every time you do an insert, update, or delete, that index needs to be maintained. So here's a quick demo. We're going to create a schema called PL demo. We're going to use that demo. We're going to create a table, and that table is called EX1, It has 3 columns in it, one called MyID. It's a type serial primary key. Second column is C1, third column is called C2, and they're both integers. Now if we do a show create table on this, this might be hard to read in the back. This is not the way I recommend creating keys, by the way. So we have our C1, C2, both integers, and you notice that myID is defined as a big integer, unsigned, not null, auto increment. The reason you want unsigned is it gives you a wider range of numbers. There's not negative numbers. And not null, once again, you don't want nulls in there. And auto increment means every time you insert a record, the server will automatically increase that number by 1 when it puts the record into the table. Here's a little bit better look at that. Now some things mentioned is you go unsigned, you get a range of 0 to 2 to the 63rd, which is usually enough for most people. Not nullable means there's no null values in a column. Null arithmetic is kind of interesting, and it's easier to make sure that you have a one-to-one record that's easily identifiable in your indexes. Now here's the contention. We have our primary key, which is the auto-incremented key, and we also have a unique key because I used the keyword serial when it was defined. In Postgres, you'll see serial used a lot more often than you do in the MySQL world. Can anyone tell me what the problem with this is? We have 2 indexes on the same table, which means we insert 1 record, we have to do 2 inserts into the index. Not what you want. What you want are auto increment records, and that will make sure the things are unique. So skip the unique key, that's the default was serial, or you can do that. So my recommendation for all your primary keys, and once again you want a primary key, is use an int or a big int, unsigned, not null, auto increment. What if you want to search the record by the first numbers in the customer ID? So like a VIN number on your car, the first couple digits tell you who the manufacturer are. We're going to, let me create a dummy table here. New table. And we're going to put in some random numbers for the last 2 columns. And when we do run explain on a query where we're looking for any records where the ID equals 7, this is the output from explain. Explain is how you see what the query plan is. You notice that the good news is we have 2 possible indexes, and it's going to use the primary by default, and we are only pull back 1 row, which is what we want. Oops. Now we're going to use the bad keys from the previous example to show some multiple possible keys. So now for comparison, let's create another table. It looks pretty much the same. The only difference is that we have the int unsigned, not null. But this case, we don't have an index on there. So when we go to look for record number 7, we have to do a table scan. The table scan means we have to read the first record to the last record to find the one we want. Now, if we add an index in there, we only have to get 1 record. And notice that in both cases, you get 1 row, but the cost goes from 1025 down to 0. And it actually gets the information from the index. It doesn't have to actually go out and read the data. Now, if you do format equals JSON, you get a little more information of what goes on. The query without the index, it has to do a whole bunch of reading, 9 versus 0, an evaluation cost of 1.1, and a prefix cost, which I won't go into, that's 10.25 versus 10.0. With explain, you can see what the various costs are to doing your query, and you usually want this lowest cost query. So, yes, sir.
I thought, well, maybe it's not in MySQL. I thought that when you create a primary key, it automatically creates an index.
Well, when you do the primary key, it does. But one of my demonstration tables did not have an index. So, indexes work. Can we just index everything in the table? Well, you can, but it's going to be very slow. It's going to soak up a lot of memory, and I'll give some more details later on that. So, what can you index? Well, as I said, you can index everything. You don't want to do that, but there's a whole lot of things you can index. By the way, you can create indexes with the create index command or use the alter table command. So I'm going to have a made-up demo here. I don't know if you made it down the Bracona booth yet to see the Yonk box. This is a box where you can twist some dials and flip some switches, and it actually changes the load on some servers running Postgres and MySQL. And you can see on the PMM, Bracona Monitoring Management display, what is affected. You can get rid of an index, you can change the running load, and I'm missing some slides. Oh, here we go. So this is a Yonk box down here. I think this is the one downstairs. By moving these dials or flipping switches, it affects the display for the database management software. So in this example, we have a fake company called Yonkbox LLC, and this is a better look at the various switches and buttons on a previous edition of it. So for our business, we're going to create a customer order table, and we're going to track everything by an order ID that we're going to call order ID, really creative there, customer ID, order date, estimated delivery date, item number, and an ID number for the worker that it's assigned to. Now, this was done because we know each Yonk box has a serial number. They're not made till a customer makes an order when assigned to a customer, a date when it's ordered, an estimated delivery date, and an item number, which in this case could be the deluxe model, the platinum edition, and hopefully maybe when we start this we know a worker is going to be assigned to. So we have this information that, in this example I pull out of the air, but this, when you're creating a project you're going to have similar information for what you're going to need to store in a table. So if you want to quickly search by customer ID, there's a way to do that, and this is one of the things we're in parentheses you're going to see. This is why you need to know how you're going to use your data when you're designing your tables. If you're doing time series data versus transactions, you're going to lay out your data a little differently. So on our little table, we're going to create an index, and we're going to call it customer order customer index. You can come up with your own schema for naming things. What I like to do is have the table name and the column name with IDX for the index number, or the index name. And then I say that I'm going to do this on the customer orders table customer ID column. Well, let's say, we'll come back to the Yonk box in just a minute. MySQL also has the ability to index geometrical information. So if you want to write your own version of Google Maps, you can do that. This is a lot tougher than it looks, even if you have a lot of geometry behind you. But MySQL has spatial indexes. What if you want to search for keywords in your data? So we're going to change our customer order table. We're going to add a column called description. It's a varchar 500. And we're going to add a full text index that we're going to call description index on the description column. Now, here we've made two modifications to a table. We've added the description column and then the full text on it. And we can use this with the match keyword. So we're going to match the description column against the word gold. And we just happen to have one record in here with that. So we have the regular, we have partials, all that. Functional indexes. This is something that came out a while ago with MySQL. In the past, if you were doing a comparison like greater than October 31st, 2021, it couldn't use an index because it had to do a whole bunch of machinations to put the data into something you can check. With a functional index, what we're doing is we're doing a computation on one of the fields. In this example, we're taking the month out of the estimated delivery column and creating an index just on that. So if we want to run a report very quickly on who's getting their Yonk box in the month of August, this type of index speeds that up. And you can see that the explain plan tells us that we did an index lookup using our new index. Now, if we want to look at another functional index, let's say we have a 50% markup on the cost of the product before we can sell it to give this the cost of the box. The great thing about functional indexes is that we're doing a computation, and whatever we want it to be, we can put it in there, and it's a valid index. Now, if we're searching using on this new index we're just creating there, you see that we get an index range scan. So instead of just going right to the index to find a record we want, it's going to be reading through a range of items in that index. MultiValue indexes. The gentleman who's speaking before me, Kenny, was kind of the father of this at MySQL. A multi-valued index is a secondary index defined on a JSON column made up of an array of values. MySQL does not have an array data type. JSON has an array. So people started using the JSON data type as an array data type. The only trouble with that is previously you could have one index entry per row. But in this case we have multiple entries on the row and we just can't have one index entry. So multi-value indexes let you get past that. So here I have some dummy data called customers. And you'll notice in the info column, we have zip codes. Your customer has multiple plants that we're shipping stuff to. So if I want to find out where the customers have a zip code of 12345, and we're going to use the member of operator to be able to come back and tell us who has that. Now, if you look at the create table, it's actually casting the info from the zip code as an unsigned array. So it does a little magic behind the scenes. Multi-column indexes. Your indexes don't have to be just one column. They can be many columns. Now, the old rule used to be put the highest cardinality or the rarest in the leftmost column and work down. If you're really interested to see me later or see me tomorrow in the booth, I can show you where you don't always need to do that. Over the past couple of years, MySQL has gotten really sharp at pushing this down to the storage engine to pull this back, so you don't always have to do that. So we're going to create another table called X, 3 columns. We're putting in some dummy data, and we're going to create an index on the 3 columns that we have, C1, C2, and C3. So if we're looking for a record where C1 is equal to 1, C2 is equal to 2, and C3 is equal to 3, it's of course going to use that index for us. Now, if I'm not looking for all that columns, what's interesting is it still uses that index. Now we're using the first 2, which kind of follows the general rule, and it's going to use that index to find what we want. Now, let's change it and look for the first and third columns. Now, traditionally in MySQL, because we're using the first and third columns, it would not use that index because it's supposed to work most exclusive, next most exclusive, and so on. But you notice in this case, we're looking for C1 equals 1 and C3 equals 3, it's still using our index. This is one of the things, I'm writing a book on indexes, and it's like, hey, this isn't following the rules that I learned. Okay, foreign keys. Anthony, you've been around MySQL, probably the only person around it longer than I have. What's the general rule on foreign keys? Well, the idea is you have a key in one table that points to a record in another table. And for a long time, people didn't like MySQL foreign keys because they didn't work very well. That reputation has held up for a lot of folks. Other folks use them without problems. This is something to test and see if you like. If you like them, fine. If you have problems with them, do all the relationship management yourself. So here we're going to create a table called X, insert some values, create an index on those values, and we're going to use the tree format on the explain pan. And we're looking for, that slide is out of order, I'm sorry. This one should have been 2 up. So now we're looking at the second and third column, where C2 is equal to 2 and C3 is equal to 3. For some reason, in this case, it wants to do a table scan. It can't figure out where to go. It doesn't have the first column, so it doesn't know how to hook that into the index. Now, let's change our data a little bit. And no, we're actually not changing the index. Yeah. Mm-hmm. Yeah. Well, I keep wondering why we're not doing bitmap scans or like Postgres. Now, sometimes you get lucky. And in this example, we're doing a select star from X where C2 equals 2 and C3 equals 3. And we're ending up with a table scan, which is expensive. Now, if we come back here and go back to where we do the direct match of C1 equals 1, C2 equals 2, and we've done our index X on the 3 columns, covering index lookup. That means that the server does not have to dig into the data to get the response to the data or to your query. It's going to give everything off the index. Here we go. My slides are out of order. I'm not sure why. I'll have to update that. This is when I was talking about foreign keys. Not sure how these got scrambled. Okay, foreign keys. We have 2 tables. Parent, and it has an ID and the primary key's ID. We have a child table, and we're going to say we're going to have an index called parent ID that we're going to call, pointing to here. Now the foreign key is going to actually reference the parent ID field in the other table. So child points to the table. The parent table. And we're also saying that whenever you get rid of a parent record, come through and delete the child references. There can be multiple child references. Okay, hash joins. This came about 2 years ago in MySQL. And if you're doing equijoins, it's much faster than an additional nested loop join. Right now, what MySQL will do is if you're joining 2 tables, it will take the smaller one, read the first line, and then a loop to the second one, pull in that data, go to the second line, and go back and forth. Now, if you're doing an equijoin, and what I mean by equijoin is you have columns that you're using an equation symbol with. it will run out and do a hash join. Hash joins are great because it basically takes everything from one table, puts it in memory, and then reaches out to the secondary table. Instead of doing one at a time, it tries to do them all at once. Okay, invisible indexes. MySQL supports invisible indexes for 4 years now. The invisible index is not seen by the query optimizer. It's not per session, it's for the entire machine. And this feature can apply to indexes other than primary keys. When you do this on a primary key, watch out. And it's much easier than removing an index for testing and then having to rebuild. So we're going to create a table. Actually, we're using the MySQL world database where the table has a bunch of city information. And if we're looking for the records where the district is equal to Texas, and there's no index there, it has to do a table scan, and the cost is $442.24. Now, if we alter the table and add an indirect index on the district, and we run the same query, it drops from 442 down to 9.10. In this case, it has to read 4,188 rows. This one only has to read 26 rows, much less work. Now, if we alter the table to make that index invisible, we go back to our old number. Now, in the old days, what would happen is you have an index that you didn't think was doing much, you blow it away, and about 3 minutes later, someone calls you on the phone saying, hey, my query's suddenly dragging, what's going on? And then you have to rebuild that index, which can take seconds, minutes, hours, longer. Histograms. This is something that also came out with 8.0 that's an option instead of running indexes. Instead of indexes, histograms let you give more information to the optimizer without the overhead of an index. The only trouble is it's for data that doesn't churn, doesn't have a lot of changes to it. The more static, the better. And the optimizer by default assumes an even distribution of a data within a column. Those of you who do any sort of analysis will find out and know that that is a very rare situation. So let's create a table called H1, and we're going to have an ID and a column called X. And into X, we put in the values of 1, 1, 2, 2s, 3, 3s, 4, 4s, and 1, 17. And if we do a select star from H1 where all the values of X are greater than 0, and by the way, big hint, they're all greater than 0. When we run explain on that, the optimizer comes back and tells us, well, I'm going to have to read 11 rows, and it's going to take, well, I know there's 11 rows, and I'm going to have to read a third of them to get the information for X is greater than 0. How many have ever played with a contractor who said, oh, I can do that in 2 days, and 2 months later you're still grinding away? This is what the optimizer said. It says, yeah, I know there's 11 rows, I only have to read a third of them, and that's the way it's going to be. Well, we know that's not true. Was the optimizer lying to us? No, it's just using bad information. So, let me go to the next one. So we're going to create a histogram. You can have up to 1,024 buckets in each histogram. And we now create a histogram on the column X. And now we say explain select star from H1 where X is greater than 0 and all of them are greater than 0. It says, hey, there's 11 rows and we have to read all of them. Now, as you change this data, it gets a little bit out of date, but you don't have the overhead of an index. So we get the better estimate there. Now, indexes are fast. Histograms can be fast. Indexes require maintenance. Histograms, you can rebuild them as you need. Once again, you're not going to use it on high churning data. Occasionally, the server will do what's called an index dive to double check the statistics to make sure that the indexes are pointing to where they're supposed to be. That can hit at the wrong time. Also, indexes takes up space in disk and memory, and that's kind of an offset there. So if you have data that doesn't change very much, consider a histogram. And if you have stuff where you really need it fast and really need it super accurate, use an index. And that was a lot to cover in the time period, and I know you all have had a long day. And I'm the person who runs the MySQL track for scale. So if there's anything we didn't cover this year, or anything you want to see, or you want to give your first talk and want me to help coach you through it till next March when we all are back in Pasadena, let me know. And by the way, the slides are up on slideshare.net/David M. Stokes, and you'll see it as the survey of indexes.